Hi everyone. Let's go ahead and talk about multiply polynomials. We start off way back when we said, hey, let's just multiply values. If I say 3 times 3, we call that 3 squared, right? If I'm multiplying, we add to the exponents. If I say 3 squared times 3 to the 4th, we said that a fast way of 3 to the 2 plus 4 is 3 to the 6th. Great. As we kept on going, we talked about variables. If I say x squared times x cubed equals to x to the 2 plus 3 is x to the 5th. And even simple things like x times x, we said is x squared. You can see this also as x to the 1 plus 1, right? Because they're both invisible ones. That's why it's 2. If I switch this back with a number, 3 times 3, right, we call that 3 squared. Back to where we started from. Well, what if the terms? What if we end up with more things to multiply? And we said we can multiply monomials 3x, that's a times x plus 2. And we multiply these out, 3x times x, and then 3x times 2. What my brain is doing is saying, hey, 3 has to multiply to 3x, so that's 3x times x. And then 3 also has to be, 3x has to multiply by 2. All right, great. And this is called distributive property. Okay, a multiplication. So we can distribute, and we have 3x times x is 3x squared, like we practiced just a little bit ago. And 3 times 2 is 6x. And then in the last class, we went and we also did binomials. We said, what if it was 3x plus 1 times x plus 2? So we went from one term to two terms, right? One term to two terms. Maybe I shouldn't use x there. But one term to two terms. And then we said, well, this one, it takes its own special case where everyone has to multiply by everybody. So we say 3x times x and 3x times 2 first. And then we say 1 times x and then 1 times 2. And we can write this out. This is what's going on in my brain. I'm saying, hey, 3x times x plus 2 first. And then 1 times x plus 2. And hopefully that wasn't too difficult. So with 3x times x is 3x squared plus 6x. Very similar to what we just did here, right? And then it's 1's turn. And 1 times 1, so 1 times x is x, and then plus 2. We always end up with like terms. That's what you always have to be careful of, like terms. And we end up with 3x squared. 6x's plus 1x, 6 oranges plus 1 orange is 7 oranges, plus 2. And this is what happens when we multiply two binomials together. Now, today we're going to go through some special cases of these binomials, some special cases. And let me go ahead and give you some of them right now, and maybe you can come up with a pattern for it. Okay? So let's do, what if they're the same binomial? What if they're twins? What if I say it's x plus 3 squared? Okay? What if then I wrote, what if it's x plus 5 squared? Okay, I'm going to give you 3 different problems. X, so 2x plus, let's say 3 squared. Okay, so let's see what happens when we deal with all 3 of these problems here. And maybe we can come up with a pattern for this. And that's the goal, to come up with a pattern to make life a little easier. Okay, so here we go. I'm going to write this my traditional way, x plus 3 times x plus 3, because I have 2 of them. Right? So I would do the same thing here, right? X plus 5, x plus 5. And here, 2x plus 3, 2x plus 3. Okay. Now, this is our traditional way of doing it. This is not our fast way we're trying to get to. Okay, this is just a traditional way. And then hopefully we can come up with a fast way of doing it. Maybe you guys can see the pattern yourself. Let's go ahead and multiply. We're going to see x times x and x times 3. We end up with x squared plus 3x. And then 3x and 3 times 3 is 9 plus 3x plus 9. Okay. Remember, these are twins pretty much multiplying each other, right? Twins are shaking each other's hands. Before I add those together, I'm going to go ahead and do the next one. We're going to end up with x times x and then x times 5. x squared plus 5x. And then now it's whose turn? It's 5's turn, right? 5 times x, and then 5 times 5. And then I liken this to when your family meets another family and everyone has to say hi to everyone. Hi, this is my wife. Hi, this is my son. Hi, this is my daughter. And then the other side says, hi, this is my wife. Hi, this is my son. This is my daughter. And then everyone has to like shake each other's hands or give each other hugs. You guys ever are in those types of families where everyone hugs everyone? Right? Ew, hugging everyone. So 2x times 2x and 2x times 3, everyone has to talk to everyone. That's 4x squared. And 2x times 3 becomes a 6x. Okay, now that's to work on the 3. 3 times 2 is 6x. And 3 times 3 is 9. Now, maybe you guys have seen the pattern already. Maybe you guys see something that's going to be repeating, perhaps. And hopefully you guys might have noticed that we always end up with the same middle terms. Okay. We also always end up squaring the front, squaring the front, squaring the front, and squaring the back. So here's the pattern. Let's go ahead and come up with the answer here. It's going to be x squared. I'm going to write this a different color, plus, whoops, wrong color, now I'm putting the wrong pen. Plus 6x plus 9. Over here, x squared, 5x plus 5x become 5 plus 5 is now 10x plus 5. On my right, we have 4x squared. 6 plus 6 adds up to become 12x. And on the right, this becomes 9. So I'm going to give you guys about 30 seconds here to see if you can come up with a pattern. And I'm going to have you guys do this next problem. Except I want you guys to skip from here to here, here to here, here to here. Let's see if you guys can come up with that pattern. Okay, see if you guys can figure out a pattern. I'll give you guys about 30 seconds, okay? Okay, let's see if you guys can come up with a pattern. Let's do a rapid fire. I'm going to give you guys a couple questions quickly and see if you guys can come up with the answer. Here we go. We have x plus 4 squared. Can you come up with what the answer is? X plus 7 squared. Can you come up with what the answer is? 2x plus 4. Can you come up with what the answer is? And let's do a change of pace. Let's do x minus 2. See if you guys come up with what the answer is. I'll give you guys 30 seconds to do these problems. All right, that's 30 seconds. See if you guys need a little more time. Okay, so let's go back and talk about the pattern now. What we see is that whenever I'm squaring something, let's go back to take a look at my first example here. When I'm squaring something, please notice that you always end up multiplying the same thing by the same thing, the front by the front. So what is the front times the front? It's always the front squared. Hey, weren't we always going to multiply the back by the back anyways? That's how we end up with a 9. 3 times 3 is 9. You always end up with the back squared. 3 times 3 is the back. And see if that works for all these other problems. X times x in the front becomes x squared. And 5 times 5 becomes 25 in the back. Oh, shoot, I messed up. That was a 25. Oh my goodness. Why didn't anyone tell? Oh yeah, someone did tell me. I just didn't write it. You're right. Okay, that was 25. Looking here at my next problem, what's 2x times 2x? 2x times 2x is 4x squared. And 3 times 3 is 9 in the back. Okay, so you get the front and the back. That's always the easiest. You square the front, you square the back. And now here's my saying. You square the back, square the front, square the back, and you double the middle. If you look at this, we always end up with 3x and 3x. We always end up with the same number, 3x and 3x. 5x and 5x. 6x and 6x. So what we do is, the trick is you just double that middle value by multiplying the two terms together. So 3x becomes 6x because we're doubling. 5x becomes 10x. And this is 2 times 3 is 6x times 2 is the 12x we wanted. So that's our pattern for all these. We square the front. This becomes x squared. We square the back, becomes 16. And we double the middle, which would have been 4x. Double 4x becomes 8x. Double the middle. We square the front. We square the back. And we double the middle. What's double of 7? 14x. We square the front. We square the back. And we double that middle. 2 times 4 is 8. 8 plus 8 is 16x. All right, we double that middle. Does it work for negatives? Yes, we still follow the same pattern. We square the front. That's x squared. We square the back. What is negative 2 times negative 2? Negative 2 squared, it becomes a positive 4. And we double the middle. This is a negative 2x, and we're going to double it, times 2, negative 4x. Now let's come up with the generic pattern for this, for all these types of binomials. So if we're adding, okay, if I say it's a plus b squared, great, so anything in the front plus anything in the back, and we square it. This always becomes a squared plus b squared in the back plus 2ab, where we're mixing our a values and b values together. To prove that to you one more time, I'm going to multiply it out. A plus b times a plus b. A times a, then a times b. We first work on our a's, a squared plus ab. Then we work on our b's. A times b is, b times a is still ab plus b squared. Please take a look. You always end up with two exactly the same terms that you're adding. That's why you always end up with doubling that middle term. So let's see if you guys can come up with this example answer real quick. If I say x plus 10 squared, what do you think goes in the front? What's the middle? And what's the end? So we square the front. We square the back. And we double that middle. We say 2ab. We say 2 times 10x. And 2 times 10x is 20x. And if you came up with a pattern, great job. If you didn't, do you understand what the pattern is now? And the idea is, the whole reason why we study math is we're looking for these patterns. And from these patterns, we can build higher combinations. Like your computer is made up of patterns. The idea of using zeros and ones to come up with a language that then you can do stuff with that language, but just saying zeros and ones, on and offs. Okay, so how does this look with negatives? If I write a minus b, okay, take a look, it's a minus b now. And it goes a squared plus b squared in the back, and we're going to say minus 2b, ab, 2ab. And the reason why is because if I'm multiplying a minus b, well, the a and a still becomes a squared. The b and b is still going to become negative, negative, become positive. And we'll see what happens. Negative 2ab. The b's turn. B times a is negative ab. And negative, negative become a positive b squared. We end up with 2 negatives. Let's see you guys do this problem. If I give you guys the problem now, x minus 4 squared. Okay, following this pattern here, we square the front, we square the back, and we double the middle. So we have x squared in the front, 16 in the back, and the middle is going to be a negative 4x times 2. Oops, sorry. Doubling 4x. We're going to double that value. So x squared minus 8x plus 16. Patterns. You don't have to write all this. You can just go from this to this. Save yourself some time. Okay, so now that we know the pattern, let's see if you guys can do the next 3 examples once again. And once you guys are done, I want you guys to type done on the chat, okay? You can put it on private if you want. You can leave it for everyone to see. But let's see how fast you guys can finish all 3 problems. Here we go. We have 1, 2, 3. Okay, here are the problems. X minus 5 squared. First problem. Second problem. 3x plus 4 squared. Third problem. 2x minus 1 squared. Okay. Once you're done, go ahead and type done so I know when you guys are done. Kind of a... Let's just start counting. I'm starting to count now. Once you guys are done, go ahead and just type anything actually in the chat. You can send that private to me, or you can let everyone see. Okay, that was done in like 30 seconds. 10 seconds per problem. Fast. Okay, we're hitting about 50 seconds now. Let's do it very quick. And we'll stop in just a little bit. We're at 60 seconds now. Good job. We're at 1 minute and 10 seconds. Okay, we're at 1 minute and 30. All right, good job everyone. So let's see if we can figure out the pattern once again using this. If we are squaring a binomial, we square the front, x squared. We square the back, that's positive 25 because a negative 5 times a negative 5 becomes a positive. And we just double the middle. The middle would have been negative 5x. We double it becoming negative, whoops. We double it becoming negative 10x. Next term seems to be harder, right? But we still follow the same properties. We square the front, we square the back. 3 times 3 is 9, x squared in the front. 4 times 4 is 16 in the back. And we double the middle. 3 times 4 is 12x. Double it, becoming 24x. Last one in the back. 2 times 2 is 4x squared. In the back, negative 1 times negative 1 is a positive 1. That's why the negatives become positive. And doubling the middle, negative 2x. Negative 2x gives us, doubling it, negative 4x. So go ahead and check your answers. If you made a slight mistake, that's fine. So the cool thing is that if we are squaring a binomial, these problems always have this pattern. Square the front, square the back, double the middle. Square, the front, square the back, right? And then we double the middle. Square the front, square the back, double the middle. Where we write a plus b is square the front, square the back, and then double that middle value. Okay. All right. So, great. What if they're the same? Positive, positive, negative. What if they're opposites from each other? What if one was positive in the middle and the other one's negative in the middle? It's like two twins, one evil and one dark. So let's see. This is called a difference of two squares. This is what the result will become. So here we go. If I say x plus 2 times x minus 2. What if I say x plus 3, x minus 3? Right? Let's look at these two examples here, and we'll see what happens. They look almost exactly the same, except one is positive, one is negative. And these are even easier than what we looked at before. So this is our second special case. First one is what if they're exactly the same. Second case, what if they're different, but only the middle is different. Here we go. X times x, like we did before. X times 2. 2 times x. 2 times 2. On the right, we'll do the same thing. X times x. X times negative 3. 3 times x. 3 times 3. Negative 3. Now I want you guys to look at what happens to these middle terms. Remember how we said one was positive and one was negative? What happens here? What happens to a positive 2x and a negative 2x? Well, they should cancel out. And what we're left with is an even shorter problem. X squared minus 4. Look on the right, negative 3 plus 3. Negative 3x plus 3x. That cancels out. That subtracts out. Leave me. This is what we have. When we have a difference, okay, we end up with what we call a difference here of two squares. This is a Q. Difference of two squares, right? That's a square, and we have a difference between those squares. And it's going to be a trick we're going to look at later, how to go backwards from that. So the cool thing here is all we do is we square the front and square the back, and we put a minus sign in between. Why do we always end up with a minus sign? Because what's a positive times a negative? That always gives you that negative. A positive times a negative always leaves you with a negative left over. So let's go ahead and do a couple more of these problems. Let's see if you guys get the rhythm. Let's say it's going to be x minus 10 times x plus 10. And 2x plus 3 and 2x minus 3. Okay, here's our next set of problems. Let's see if you guys can do these problems quickly. X times x is x squared. Now, I'm doing the slow way, okay? But you guys can jump to the answer. If you see the pattern, go ahead and jump to that pattern. Okay. If you guys know the pattern, jump to the pattern. I'm just taking my time here. Alright, and hopefully you might see also, like what we just saw before, that our middle terms cancel out. And we're left with x squared minus 100 and 4x squared minus 9. Okay, and this is a super cool trick. This happens a lot. You'll see these a lot. And the idea is you can just go from here to here, from here to here. The middle terms will always cancel out, the plus and minus. It's almost like who are equal equal superheroes. There's no one really. Like Captain America and Iron Man, when they punch each other, they knock each other out, I guess. Alright. So, following this trend, we're going to talk about what if I just multiply. Let's go back to just multiplying now, right? So these are our two patterns. Oh, let me give you guys a generic pattern for this. If I say it's A plus B times A minus B, right? Look at them. They're positive and negative. This becomes A squared minus B squared. Don't worry about the middle terms. We knew that they were going to cancel each other out anyways. So if I say 3x plus 2 and 3x minus 2, the rule says, hey, if your A is 3x and your B is 2, all right, we just take 3x squared minus 2 squared, and we're done with the game. 9x squared minus 4. Okay, so let's go back to do one more thing today, and that's giving us a general case for any problem now. If we are multiplying polynomials by polynomials, if I said x plus 2 times x plus 3, so let's go back to this general case. The skills that we learned originally completely apply. Okay, so we say x times x, x times 3, 2 times x, 2 times 3, right? We're taking turns. X times everybody, and then 2 times everybody. We said you could skip this step here. That is perfectly fine to skip this step. But this is what is going on in my brain. We end up with x times x is x squared, x times 3 is 3x, 2 times x is 2x, and 2 times 3 is 6. Having like terms, we say x squared plus 5x plus 6. And this isn't hard to do because there's only 4 terms I'm writing. 2 times 2, 2 times 2 is 4, right? I have 4 terms I'm going to write out. But I want to give you guys a special skill / secret. What if I'm multiplying by more terms? What if I say this x plus 2 times x squared plus 3x, x squared plus x plus 3. What if I'm multiplying 2 by 3? 2 terms by 3 terms here. Does this change that much? And the answer is it doesn't change that much. It just gives us more work, right? Your parents have 1 kid, not terribly hard. If you have 2 kids, you still got to feed and clothe the kids. You have 3 kids, you're still feeding and clothing. Do all the same thing for all the kids. Here we go. So we're going to say x by the front, x by the second, and then x by the third. The idea here is that we are multiplying x by everyone in the back. Then whose turn is it next? It is 2's turn to multiply everybody. Now it's 2's turn to multiply everybody. Now again, you don't have to write this here. This is just what's going on in my brain. But let's see what practically happens. When I'm multiplying x times, let me erase this again and show you guys the steps at which we're doing this. X times x squared is x cubed. X times x is x squared plus x squared. X times 3 is plus 3x. Now, what we could do is we could write this as one long line, and let's do this right now. 2 times x squared is 2x squared. 2 times x is 2x. And 2 times 3 is 6. Now, we had 2 terms times 3 terms. That gives us a total of 1, 2, 3, 4, 5, 6 terms. Now, as I mentioned before, we're always going to have like terms. So let's look for those like terms. We have x cubed. Any other x cubes that you see in this problem? Okay, nope. How about x squares? I see x squared here, and that's 3x, 2x squared, and no more like terms. How about x's? I see x's here and x's here. And then we're left with a constant 6 by itself. So we have to combine these terms here because these are like terms. And we can reorder this because we're just adding polynomials. Is we can say it's x cubed plus, okay, I'm going to write this once and only once. I'm going to write the long way so you guys can see where these numbers are coming from. The x squares go together, the x's go together, and the constant goes at the very end, right? These are our like terms. These are our like terms. X cubed, 1 plus 2 is 3x squared. 3 plus 2 is 5x plus 6. Seems like a lot of writing. But I'm going to teach you a skill of sorting them so their like terms are right on top of each other. So this is fine. Us writing it out this way, then rewriting it, sure. But let me go ahead and show you another example here in which I'm going to ask you guys to practice this skill. And this skill is lining up like terms together already. And this is going to be an important skill for us. Here we go. We're going to do a problem similar to that. X minus 2 times x squared plus x minus 3. Okay, I changed the problem slightly just to make sure it's not the exact same problem. And what we're going to do is we're going to multiply just like what we did before, everybody by everybody. Everyone in front by everyone in the back. So we end up with x times x squared is x cubed, x times x is x squared, and x times negative 3 is negative 3x. Nothing has changed, right? This is exactly what we did up here. That's exactly the first 3 moves. But instead this time of me multiplying negative 2, and I'm not going to write it here. I am not going to write it here, okay? I'm going to write it over here. And let me show you what I mean. When we wrote it this way, we had to look for like terms. We were searching for like terms. I'm going to show you a way of writing it so the like terms are already next to each other. Here's what we're going to do. 2 times x squared, negative 2 times x squared is negative 2x squared. So instead of writing it here, I'm going to write it next to its like term. So they're already lined up. Negative 2 times x is negative 2x. Instead of writing it up here, I'm going to write it over here. So they're all lined up. And 2 times 3, negative is a positive 6. Now if you look here, we just have to combine like terms. Negative 2 plus 1 is negative 1. 3 and 2, both negative, become 5. So please, this is what I want you guys to practice. Lining up your polynomial, especially since there's so many terms, that the like terms are already lined up by writing them on top of each other. And that's really the skill I want you guys to work on. Multiplying isn't terribly hard, but writing them on top of each other will save us time. We're still doing the same amount of work that we did back here, except we actually stopped here, from here to the answer. And we don't have to look for like terms, because like terms are on top of each other already. Okay, let's do it one more time. Here's my next example. 2x plus 3 and x squared plus 4x plus, let's do minus 1. Okay. So let's go ahead and practice this problem. First we multiply everyone by 2x, 2x, and 2x. We end up with 2x times x squared is x cubed because I have 3 of them now. 2 times 4 is 8, x squared. And 2 times 1 is negative 2. Alright, we're done with 2x. It's 3's turn. Here we go, 3. 3, 3, 3. 3x squared, because they're like terms. See how I wrote them right on top of each other? Then 3 times 4 is 12. Oh, sorry, I forgot my x here. Right, 2x times negative 1 is negative 2x. And then, yeah, we end up with 12x and minus 3. So we have 2x cubed. 8 and 3 become 11. 12 and 2 become 10. And minus 3. That's it. We ended up with 6 terms. Right? 2 times 3 is 6. But we were able to reduce those to only 4 terms, because we had like terms. All right, so that's your homework for today. And that's actually the last topic we'll be covering for our test number 2.